So now, today we are going to start the chapter number 3. That chapter, its name is Motion in a Straight Line. Suppose if you think about any kind of a motion. Suppose if car moving on a straight road, that's motion in a straight line. If we think about any object, that's the position changes with respect to time. Ultimately, that's in a motion. In this chapter, we are going to detail discussion that why that motion is take place, what's the causes, what's the reason behind that motion. So here, almost in this chapter, we are going to think about that velocity, acceleration, that instantaneous velocity, instantaneous acceleration, as well as we can discuss about that relative motion. So here, first point in this chapter, it's about this kinematics. So what do you mean by kinematics? A branch of physics dealing with motion without considering its causes, it's known as kinematics. मतलब अगर मान लो कि मोशन हो रहा है, we are not interested कि क्यों हो रहा है, that is called as a kinematics. Means in that branch we are not dealing with its cause. Motion हो रहा है. But that other part, that other branch, that we call as the dynamics. That's a branch of physics describing a motion along with its causes and properties of a moving body is called dynamics. For example, if a body rolling on inclined plane, so what's the reason behind it? Is that motion is a rolling without slipping or without slipping? Means with slipping or without slipping? If there is a motion on a circular path, if there is any kind of a gravitational force or a frictional force, so if we just think about its causes, means its properties, that is part is considered the dynamics. And the combination of kinematics and dynamics, that called as the mechanics. So here, that kinematics and dynamics are collectively known as mechanics. So in your 11th standard, that physics, that first part, it's about the simple mechanics. In the second semester, you will think about rotational mechanics. Rotational mechanics means a body, if moving on a circular path, if it's moving about a fixed point, that is called as the rotational motion. That's a part of a rotational mechanics. In the second semester, there is also one more chapter that is called as the fluid mechanics. Means when we are dealing with liquids as well as gaseous, and it's a motion, means that combined branch with cause as well as without cause, if we think about that motion of the particle. Maybe it's a particle of a part of a solid, maybe it's part of a liquid or a gas. That we call as a mechanics. So now here, we can say that after mechanics, first we have to understand what is a particle. So here we consider a particle is a point-like object that's endowed that with mass. Means a particle which possesses a small mass, that is called as a particle. कोई भी particle हो सकता है. If we think about a body moving on a circular path, so that each and every particle also performing a rotational, means a circular motion. If we think about any system with a huge dimension, for example, if you think about the gravitational force between Earth and Sun, so with respect to the distance from the Earth to Sun, that Earth as well as Sun is considered as a particle. So here we can say that in terms of a comparison, in terms of a long distance, that small size is considered as particle here. So now, basically that particle which possesses a mass and which size is like a particle, it's a very small size. Here, next one is an important point, that's called as the frame of reference. Frame of reference. It means what? In the normal terms, by the definition, you can say that from or a place or a situation from where an observer takes his observation, it's called as a frame of reference. For example, अगर मान लो कोई गेस्ट आया है, आप उसको रेलवे स्टेशन पे ड्रॉप करने गए हो, for you, अगर मान लो कि उस ट्रेन में बैठ गए, so for you train that will be in a motion, आप कहोगे कि ट्रेन अभी अभी जा रहा है. But a person who is inside the train, for him, वो क्या कहेगा? वो ये कहेगा कि भाई ये सो एंड सो स्टेशन है, वो चला गया, पर स्टेशन कहीं नहीं जा रहा है, उसका ट्रेन है वो मोशन में है. So with respect to stationary earth, that train in a motion, and a person who is inside the train, for him that train is a stationary, and with respect to train, that earth in a motion. So a person who is outside the train, for him that earth as a whole reference frame, and a person who is inside the train, for him that window or that frame where he takes his observation. तो ट्रेन उसका रेफरेंस फ्रेम बन जाएगा, और जो आदमी प्लेटफॉर्म पे खड़ा है उसका प्लेटफॉर्म है वो फ्रेम ऑफ रेफरेंस है वो बन जाएगा. फॉर एग्जाम्पल, अगर मान लो कि हमारे पास यहां पे एक सिंपल सा फिगर दिया गया है. सपोज इफ यू थिंक अबाउट दैट पार्टिकल ए, if you think about that particle A, a little bit in x direction, little bit in y direction, little bit in z direction. So here that particle A, that's something in x, something in y and something in a z direction. So if that motion, मान लो कि ये कोई, it's a motion of an ant. Okay, मान लो कि कोई यहाँ से उड़ के आ रहा है या तो जा रहा है. For example, it's a fly, you can say. Motion of a fly, that's in a 3-dimension motion. So if I think about that position that changes from x1 to x2, y1 to y2, and from z1 to z2. Suppose if you take a simple end, so that's the motion only in x direction, either that's in the y direction, or maybe that's in a z direction. If you can say that a football player that's running in the ground, so that is considered a motion in a 2-dimension. And if you think about a fly, so that's the motion in a 3-dimension, a little bit in x direction, in y direction, as well as in z direction. So here, I just tried to clear that concept about 1-dimension, 2-dimension, and 3-dimension. 1-dimension, motion of an ant. मान लो कि एक चींटी ले ली, just placed on a wire. Either that ant will move on x direction, वायर को ऐसे वर्टिकल कर दिया, so that will move in y direction or negative y direction, and that will move in a z direction. So at a time it can move only in 1 dimension. If you think about football player, यहाँ वहां भाग रहा है, so here you can say that the motion of football player, that's a 2-dimensional motion. And if you think about a fly, makhi, it can fly in all the directions, either in x or in y or in z. अगर मान लो आप पैराग्लाइडिंग की बात करते हो, शायद आपने कभी देखा हो तो पैराग्लाइडिंग इज व्हाट? मान लो कि जो पर्सन पैराग्लाइडिंग करने वाला है वो पहले जो भी ग्राउंड है वहां पे भागेगा, एंड देन ही जंप, देन ही विल फ्लाई. So that's the motion in a 3-dimension. So here, if you understand what is the 1-dimension, 2-dimension, 3-dimension, so this concept, that the motion in a straight line means the motion in a 1-dimension, we can easily understand. After this point, we can say that first point is that what do you mean by position? So position means what? Suppose if I consider one straight line, suppose that's in a x direction. Here if I consider 0, 10, 20, 30. All I just consider that's a distance, and that distance in kilometers. For example, here it's in negative direction, so I can consider as a minus 10, minus 20. Now suppose if I consider here, that's a body A, that will first of all move in up to this point. So that point you can say it's a 20 kilometers, means it's a B point. Now from B to C, So next position, that's again 10 kilometer. So position means what? At any time, that situation of the particle, that we call as a position in the simple terms. Now suppose if that any particle from the C, now that will move in opposite direction up to this point, and that point is a D, and here it's a minus D. So total displacement means start from the A, reach at this point. So total displacement is this only. This you call displacement. But if you think about path length, it means path length that is from A to B to C to D. It means from A to B, then B to C, and then C to D. And that is considered the total distance. So here you can say that displacement means what? So displacement means change in the position, that is the displacement. Suppose if you say that start from the A point and then end with minus 10, it means yahan se yahan tak hi ho gaya, means 10 kilometer but in opposite direction. So that displacement value is minus 10. But the path length, minus 10, minus shows that a position of that particle 10 kilometer but in opposite direction. Due to that reason there is a minus sign. But if you think about the path length, so path length means what? From A to B distance, B to C distance, and then move C to D distance. And path length is always considered as a positive. For example, if you say here that is a A to C, means it's a 30 kilometer. Again that's moving this direction, so 30 plus 30 60, 60 plus 10, that's a total 70 kilometer. So here you can say that path length value is 70 kilometer and displacement is minus 10 kilometer. Again let me clear this minus sign because of that's in the opposite direction. And path length means whatever that total distance covered by the particle, that is called as a path length. And the position means that as we observe, as we mentioned, position means situation of any particle at that specific point. So here you can say that now the path length. The path length means the total distance traveled by a particle in some time interval. That's called as the path length. So as we just observe, in this point, that path length is total 70 kilometer, total distance covered here. So total distance from A to B to C and then come back with the D. So total distance, that's the 70 kilometers. So now path length means we can say that total distance traveled by a particle in a some time interval is called path length. As we just observe in this previous slide, and that is about that path length means total 70 kilometer distance. Because that particle moved from A to B, then B to C, and then C to D, that total distance is considered as a path length. Where the displacement, that is the change in the position, that is called as a displacement. So now here, after path length, here we have the displacement, and yes, as I mentioned, displacement means change in position of particle in some time interval is called a displacement. पहले कहाँ थे, अब कहाँ है, that is known as a displacement. Path length मतलब कितना distance cover किया. For example, if a particle moving on a circular path, if any particle moving on a circular path, after completing one circle, जहाँ से start किया वो वहीं का वहीं है. So in that case, you can easily understand that the displacement of that particle is 0. But if you think about the path length, मतलब उसने cover तो किया है distance. So that covered distance is equivalent to circumference. Is that clear? That's about, it's an important point, that path length is always positive. So here, that path length is always considered positive, because path length means what? Distance covered by a particle. So कहीं पे भी जाओ, right है, means right side or a left side, in any direction. Path length मतलब जो भी distance cover किया वो. You can take a very simple example. अगर मान लो आपको एक जगह पे ऑटो रिक्शा आपने हायर किया, आपने कहा कि भाई मुझे एक्स पोजीशन पे पहुंचना है, वो ऑटो रिक्शा वाला आपको घुमा घुमा के वहीं पे अगर आपको लेकर आएगा पिछली गली में, मतलब क्या, तो क्या उसने तो रिक्शा घुमाया, मतलब उसका तो जो रेंट होता है वो आपको देना पड़ेगा, टैरिफ जो भी होगा वो आपने दे दिया। बट देन यू रियलाइज कि एक्चुअल में डिस्प्लेसमेंट तो कितना कवर करना था, तो कि एक गली से सिर्फ दूसरी गली में आना था। सो पाथ लेंथ मीन्स आपने जो भी डिस्टेंस कवर किया एंड दैट ऑलवेज पॉजिटिव। पर अगर मान लो आपने जहां से स्टार्ट किया घूम के वापस वहीं पे आ गए, सो डिस्प्लेसमेंट इज 0। आप स्ट्रेट पाथ पे गए मीन्स पॉजिटिव डिस्प्लेसमेंट, और जहां से स्टार्ट किया अगर मान लो आप उसके ऑपोजिट डायरेक्शन में जा रहा है, सो इन दैट केस द डिस्प्लेसमेंट will be negative. So here you can say that the displacement can be positive, negative, or that is also considered as 0. So it's an important statement.